Hello everyone. In this video, we'll solve LeetCode problem number 19. Remove nth node from the end of the list. Now, this is one of the very simple yet interesting problems that has been asked in many companies like Amazon, Google, Meta, Microsoft, Apple, TCS. Let's try to understand the question first. Given the head of a linked list, remove the nth node from the end of the list and return its head. So, this question says that you would be given a linked list and you need to remove the nth node from the end of the list. So, let's suppose the list looks something like this: 1, 2, 3, 4, and 5. You need to remove the nth element, which is 2 in our example. So, you need to remove 4 from the end, which is our second node, and you need to return 1, 2, 3, and 5. Okay, similarly you can look at other examples when we have just the head and the node we have to remove is 1 from the back. We need to return an empty array or empty linked list. Similarly, in our example number 3, we have a linked list of 2 nodes and we have to remove one node from the end. So we need to remove this 2 from here and return 1. Okay. So to do this, I would be using 2 pointer approach here, and also I would be using a dummy node. Now, before we dive deep into all these concepts, let's see how I have solved it. So, first I have declared one dummy node, and this dummy node would be added before the head. The reason why we are adding this dummy node because it makes it easier to delete the head if needed. For example, in our case 12, in our case 2, example number 2, head needs to be deleted, so such cases becomes easy. In line number 10, as you can see, I'm attaching dummy to our head. So our entire linked list has a new head, which is the dummy node. Now I am taking 2 pointers here. One would be our fast pointer and one would be our slow pointer, and initially both our pointers would be at the dummy, which is the head of the newly created link node. Okay. Now in this part, what I am doing is I want my fast node to be n plus 1 step ahead. Okay, I want it to be ahead of the n pointer that has been given to us. This extra 1 step ensures that when fast reaches the end, slow will be right before the node we want to delete. And to do that, what I'm doing is I have a for loop here. In our for loop, I have initialized one I is initially 0 and it goes up to n, and in every loop I increase the value of I by 1, and in every iteration what I do is I move my fast node to fast dot next node so that it reaches our destination point. So taking this example, I want my fast pointer to be at 3. Okay, so this makes sure that it happens. Now in the next part, what I've done is I've initialized a while loop. Now this while loop keeps moving till our fast become null. Okay, and during that time what I do is I keep moving my fast to the next pointer and slow also to the next pointer. Once this is done and fast reaches null, what I now do is I say that slow dot next is equal to slow dot next. So once our while loop ends and we see our slow see where our slow is, you will find that our slow is at 2. Okay, now slow dot next, which is 3, equals to slow dot next, which would be 5. So 4 would be removed, and after doing that we'll simply return dummy dot next. So this will, since dummy dot next is the head of the head that we were shared, so it will return the output linked list. Now how it works, um, suppose our given linked list looked something like this, and the node that we had to delete was the second node from the end, which means 4. So in our first step we added a dummy node. As you can see, we added a dummy node, and um, we added a dummy node here, and then we had 2 pointers, fast and slow. So both fast and slow, they are initially at the dummy node. Next what we did was we moved fast pointer ahead n plus 1 steps. So as you can see, 0, 1, 2 and 3, we moved our dummy pointer to 3 in using a for loop. So our dummy pointer is at 3, and our start slow pointer is still at dummy. Now what we did was we used a while loop, and in that while loop we are moving both the pointers together, and we are moving them ahead till our fast pointer becomes null. So in the first move our slow pointer comes here and our fast pointer comes here. In our next move, slow pointer moves ahead again and fast pointer again moves ahead. Then in our third move, our fast pointer, it becomes null, and slow pointer, it comes here. Okay, and this is the point where um, we do the switch. What we do here is we say slow dot next, which is 3 is equal to slow dot next. So we are simply removing this joint from here. We are simply removing 4 from our example, and it would look something like this. So before it was 3, 4 and 5. Now 3 is directly connected to 5. Okay, and since we are returning dummy dot next, the dummy node has been skipped, and we are returning this particular linked list where 1 is connected to 2, 2 is connected to 3 and 3 is connected to 5. Now why we moved our fast by n plus 1? So we want slow to stop one node before the node we want to remove. Okay, so to do that we need to understand where exactly slow has to stop, and the final position of slow would be something like this. Now slow dot next would be um, the node where we want to make the change, and we want to skip and get the next position, which is 5, from slow dot next to take its place. So slow dot next currently has 4. We are assigning it the value of 5. Okay, and if we moved fast only n steps instead of n plus 1, slow would end up on 4 instead of 3. Then slow dot next would have removed 5, which is incorrect. That is why we needed our slow. So just to reiterate, we'll first have a dummy node. We'll add this dummy node to we'll add our head to our dummy dot next, and then we'll have two pointers, fast and slow, both starting from the dummy node. Then we'll have a for loop, and this will go till the fast reaches n plus 1 step ahead, and then in our while loop we'll run it till our fast is null, and we'll move both the pointers one step ahead. Once we come out of the while loop, we do our assignment where we say slow dot next equal to slow dot next, so that the node that we want to delete is removed, and then we return dummy dot next, the head that is supposed to be returned. Okay, the head of the modified linked list. So this is how we solve this problem. Let's try to run this and see the result. And all the cases are passing. Let's try to submit it. It beats 100% of the solution, so that's a good thing. Thank you. Thanks for watching.